Welcome back. For this topic, we will talk about Hadoop administration. Hadoop administration involves administering, monitoring, troubleshooting, and maintenance, which are essential for processing and storing big amounts of data, often ranging from terabytes to petabytes. As an open source framework, Hadoop is designed for scalable distributed processing and storage, making it ideal for handling big data workloads. As we can see here, since it is important for processing big data from terabytes to petabytes, however, big data has no technology that can store unlimited data. And also, it has no technology that can process within the given time. So, as a solution to the problem, Hadoop administration is indeed critical for ensuring the smooth operation of Hadoop clusters, which are designed to handling massive amount of data. Here are a more detailed breakdown of the key characteristics as I mentioned. First, reliable. Hadoop's architecture is designed to handle hardware failures slowly. It achieves this through data replication across multiple nodes, making sure that data remains available even one or more nodes fail. Second, flexible. Hadoop is flexible in its ability to process structured, semi-structured, and unstructured data. This is made possible by its compatibility with various data processing tools and frameworks, such as MapReduce, Apache Pig, Apache Hive, and so on. Three, economical. As an open source framework, Hadoop significantly reduces the cost of data processing. It can run on commodity hardware, which is less expensive than specialized systems, making it an economical solution for big data storage and processing. Last but not least, scalable. Hadoop is designed for scalability. It can easily scale out by adding more nodes to the cluster, allowing it to handle increasing amounts of data and workload without significant changes to the core architecture. The history of Hadoop is a fascinating journey of innovation in big data processing. Here's an overview. From this diagram, the flowchart of the timeline, the early beginnings began from 2003 to 2004. The story of Hadoop begins with a series of papers published by Google. In 2003, Google released the paper on the Google File System, GFS. And in 2004, they followed it with a paper on MapReduce, a programming model for processing large datasets. These papers laid the foundation for what could become Hadoop. The birth of Hadoop, it's between 2005 and 2006. Hadoop originated as part of the Apache Nudge project, which is an open source web search engine. Joe Cutting and Mike Caffarella were working on Nudge when they realized the need for a distributed computing solution to handle massive amounts of data, inspired by Google's GFS and MapReduce papers. In 2006, Joe Cutting, who was working at Yahoo at the time, separated Hadoop from Nudge, making it an independent project under the Apache Software Foundation, ASF. It was named after Cutting's son's toy elephant. Following by the early development was between 2007 and 2008. Yahoo became the primary contributor and user of Hadoop. They used it to power their web search engine, making it the largest Hadoop production cluster at the time. In 2008, Hadoop became a top-level project under the Apache Software Foundation, signaling its growing importance and stability. The rapid growth was between 2009 onwards. Around this time, various other projects began to emerge around Hadoop, creating what is now known as the Hadoop ecosystem. This included Apache Hive, a data warehouse infrastructure, Apache Pip, a high-level platform for creating MapReduce programs, and Apache HBase, a distributed, scalable database. Therefore, Hadoop is a solution to the storage and processing problems. Hadoop is an open source framework that allows for the distributed processing of large datasets across clusters of computers using simple programming models. As we mentioned before, it is designed to scale up from a single server to thousands of machines, each offering local computation and storage. Some key components. Fundamentally, there are two key components of Hadoop. First, the HDFS, Hadoop Distributed File System. The purpose is the storage system used by Hadoop applications. It provides high throughput access to applications data and is designed to store very large files across multiple machines. Whereas MapReduce is a programming model for processing large datasets with a distributed algorithm on a cluster. It simplifies the processing by breaking it down into two main steps, map and reduce. As we notice, Hadoop users, it is not only limited to Yahoo, Facebook, but also heaps of users platform like eBay, Target, Netflix, NASA, Amazon, Expedia, Airbnb, so on and so forth. Some of the Hadoop features, by comparison between RDBMS, which is known as the traditional relational database management systems, and Hadoop, reveal significant differences in terms of architecture, data handling capabilities, and use cases. So some of the detailed comparison between both of them. First, it is cost effective. For RDBMS, the traditional setting, it is expensive and it requires specialized hardware and software licenses, leading to higher costs, especially as data volume grows bigger. For Hadoop, it runs on commodity hardware and is open source, reducing both hardware and software costs significantly. Large cluster of nodes. RDBMS, such as Oracle, it needs a cluster size with a maximum 256 machines. And it consists of Teradata, Vertica, netizen, which requires up to 512 machines. It has a limitation, whereas for Hadoop, it does not have limitation. It could up to thousands of machines. It can take hundreds, thousands of server machines in a cluster. It offers more computing power and huge volume of storage. All right, I wish to extend a little bit about the Hadoop features in terms of fault tolerance. For the traditional setting, RDBMS system often depends on backup, replication, and high availability architectures to make sure fault tolerance. Traditional RDBMS system can suffer from single points of failure unless additional, often expensive mechanisms are in place. Whereas for Hadoop, HDFS automatically replicates data across multiple nodes, making sure that the system remains operational even if some nodes fail. Hadoop is designed to detect and handle failures, automatically redistributing data and tasks. For the performance, the traditional RDBMS excels in environments where data is structured and complex queries need to be processed quickly. The performance can degrade as the size of the data grows, especially if it exceeds the capacity of the hardware. However, for Hadoop, it designed for high throughput processing of large data volumes, but can be slower for real-time processing. Leverages parallel processing across distributed nodes, which can enhance performance for specific tasks. This is the advantage of Hadoop. The choice between RDBMS and Hadoop really depends largely on the specific requirements of the application, including the type and volume of data, the need for real-time processing, and budget constraint. In short, RDBMS is best suited for application where data is structured, consistency, and transactional integrity are paramount, and real-time processing is required. Whereas for Hadoop, it's perfect for handling large-scale data processing, specifically when dealing with a variety of data types and where cost effectiveness, scalability, and fault tolerance are priorities.